Here's a thought experiment. You're stranded on a deserted island. Day 3. You haven't eaten. Your stomach has moved past growling and is now filing formal complaints with your entire nervous system. You look around and find two things. First, a pile of crickets, hundreds of them, right there, available, wriggling, packed with complete protein, healthy fats, iron, zinc, calcium, and B12. Second, a single slightly bruised apple. Almost every Western person reading this knows, intellectually, that the crickets represent dramatically more nutrition. They know the apple is going to do essentially nothing for their caloric needs. They know that 2 billion people on this planet eat insects regularly and are perfectly fine. They know that gram for gram, crickets outperform chicken on multiple nutritional metrics. They know all of this. And they are still going to eat the apple. They might actually go hungry before touching the crickets. They will stand there, literally starving, looking at an abundant, nutritious, freely available food source and experience something so powerful that it overrides the survival instinct itself. That something has a name. It has a history. It has a neuroscience. And unpacking it reveals one of the most fascinating case studies in the entire field of human psychology. A story about how culture shapes biology, how disgust became a dietary philosophy, how geography created culinary identity, and why the most efficient food source available to humanity is being overlooked by roughly a third of the global population, while the planet quietly runs out of the resources needed to produce the alternatives they insist on instead. This is not a simple story, and it does not have a comfortable ending. Start with the numbers, because the numbers are the reason this conversation exists at all, and they need to be on the table before anything else. Producing 1 kilogram of beef requires approximately 10 kilograms of feed. It requires somewhere between 15,000 and 20,000 liters of water, depending on the production method. It produces greenhouse gas emissions equivalent to driving a car for roughly 70 kilometers. It requires substantial land for grazing, for growing feed crops, for the infrastructure of industrial livestock production. And it delivers per 100 grams of edible product approximately 26 grams of protein. Producing 1 kilogram of crickets requires approximately 1.7 kilograms of feed. It requires roughly 1 liter of water. It produces greenhouse gas emissions that are negligible compared to cattle. Crickets produce minimal methane, one of the most potent agricultural greenhouse contributors. It requires a fraction of the land, and it delivers per 100 grams of edible product approximately 21 grams of protein, along with complete amino acid profiles, significant healthy fat content, chitin fiber with prebiotic properties, and micronutrient density that rivals or exceeds conventional meat on multiple measures including iron and zinc. The feed conversion efficiency gap between crickets and cattle is not a rounding error. It is a factor of 6. For every unit of nutrition you want to produce, insects require roughly 6 times less input than the most popular conventional meat source in the Western diet. When those inputs are water, land, and carbon emissions, 3 of the most critically constrained resources in the trajectory of human civilization over the coming century. A factor of 6 is not an interesting fun fact. It is an emergency. There are 8 billion people on Earth. The global population is projected to reach somewhere between 9 and 10 billion by mid-century. Feeding that many people requires either dramatically expanding the resource footprint of food production, which is running into hard ecological limits, or dramatically improving the efficiency of what we produce. Insect protein is the most compelling answer available that doesn't require either lab-grown meat infrastructure at enormous scale, or the wholesale global conversion to plant-based diets that has so far proved culturally impractical. And yet, the crickets sit there, uneaten, while the slightly bruised apple disappears. The psychological mechanism behind this is called disgust, and it is one of the most powerful and least understood forces shaping human behavior. Disgust is not simply dislike. Dislike is a preference. You might dislike cilantro, avoid it when possible, but eat it, without distress in a dish where it's present. Disgust is a full-body response involving nausea, facial expressions of rejection, increased saliva production, elevated heart rate, and the activation of brain regions associated with threat detection and contamination avoidance. Disgust feels to the person experiencing it like a moral and physical certainty that the object of disgust must not enter the body. The evolutionary origin of disgust is relatively clear. It began as a pathogen avoidance system, a way for animals to avoid consuming things that could make them sick. Rotting meat, feces, diseased tissue, unfamiliar biological substances, these things often carry pathogens, and an animal that felt visceral revulsion when encountering them and avoided consumption had a survival advantage over one that ate freely. The disgust response is ancient, and in its original domain it was genuinely protective. But disgust in humans underwent an extraordinary expansion. It stopped being purely about pathogen risk and became a cultural tool applied to social violations, moral transgressions, outgroup members, and, critically, food categories that were culturally designated as inappropriate regardless of their actual safety or nutritional value. The same neurological response that protected ancient hominins from eating rotten meat now fires in many Western brains when encountering a plate of fried grasshoppers at a Thai street food stall. The problem is that the disgust response does not come with a label explaining its origin. When a Western person encounters insects as food and experiences disgust, the disgust feels like information, like the body's wisdom signaling that this thing is dangerous, inappropriate, or wrong. It feels like the same signal that fires near genuinely dangerous things. But it is not the same signal. It is a learned, culturally transmitted response wearing the neurological clothing of an innate protective mechanism. This is what makes food disgust so difficult to reason with. You can show someone every nutritional comparison, every environmental statistic, every cultural example of insect consumption, and they will agree with you intellectually while their body continues to insist at a level below argument that the cricket is unacceptable. Here is where the story gets culturally interesting, because the distribution of insect eating across the globe is not random, and the pattern reveals exactly where this disgust response came from and why it landed where it did. Roughly 2 billion people eat insects regularly. This is not a fringe behavior. It is mainstream dietary practice across substantial portions of Asia, Africa, Latin America, and Oceania. In Thailand, fried insects are street food, the equivalent of hot dogs at a baseball game in terms of cultural ubiquity. In Mexico, chapulines, toasted grasshoppers, are a pre-Columbian food tradition that persists robustly in contemporary cuisine. In the Democratic Republic of Congo, caterpillars are a significant protein source and a commercially important food commodity. In Japan, certain insects have been traditional foods for centuries. In Cambodia, fried tarantulas, arachnids rather than insects technically, but in the same psychological territory, are a popular snack. The regions where insect consumption is culturally normal are not defined by lack of alternatives. Thailand has abundant access to conventional proteins. Mexico has a diverse and sophisticated food culture. Japan is one of the most food-innovative nations on Earth. These cultures eat insects not because they have no other options, but because insects were incorporated into their food traditions before any cultural force arrived to designate them as inappropriate, and that designation therefore never took hold. The regions where insect eating is culturally taboo correspond with remarkable precision to the historical reach of Western European cultural influence. Northern Europe, North America, Australia. Populations descended from or heavily shaped by Northern and Western European culinary traditions have the strongest disgust responses to insect consumption. And the reason for this is, at least partially, traceable to specific historical and ecological factors that shaped European food culture in ways that never incorporated insects. Northern Europe, during the period when food cultures were being established, was not a rich environment for insects. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. The climate is cooler, the insect population smaller, the seasonal availability more limited. Populations building food cultures in these environments simply didn't develop culinary traditions around insects because insects weren't the reliable, abundant food resource in northern latitudes that they were in tropical and subtropical regions. When those populations then expanded their cultural influence globally through colonization and economic dominance, they exported not just their food practices, but their disgust responses, framing insect consumption as primitive, uncivilized, or inappropriate in ways that carried the authority of the dominant culture. This cultural transmission of food disgust is not ancient history. It is recent, documented, and its effects are measurable in exactly the distribution of insect-eating practices we see today. Now, take a closer look at what Western people are actually eating instead, and consider how deeply strange it is when examined from the outside. Shrimp, lobster, crab. These are arthropods, the same biological phylum as insects, which includes creatures sharing fundamental body architecture. Shrimp and insects are more closely related to each other than either is to fish or cattle. A shrimp is, biologically, closer to a cricket than it is to a salmon. And yet, in Western food culture, shrimp is luxury food, served at weddings, eaten by the handful at cocktail parties, considered a marker of quality dining. Lobster, which was once considered poverty food fed to prisoners in colonial New England because it was so abundant it was essentially worthless, is now one of the most expensive items on upscale restaurant menus. The people eating lobster bisque and recoiling from a cricket cracker are not responding to a meaningful biological distinction. They are responding to a cultural designation. Shellfish, through the accidents of history and the particular food cultures that developed around coastal European and eventually American dining, ended up on the acceptable side of a line that insects ended up on the wrong side of. The line is real in its effects. It is not real in any nutritional or biological sense. Cheese is another instructive case. Cheese, examined without cultural context, is the fermented, mold-processed product of another animal's breast milk, allowed to age until bacterial activity transforms it into something pungent, often runny, sometimes covered in visible mold, and occasionally moving with mites. Blue cheese is deliberately inoculated with penicillium mold and allowed to develop throughout its interior. A properly aged Époisse de Bourgogne, one of the great French cheeses, smells so intense that it is banned from French public transportation. People pay significant money for this. They serve it at dinner parties. They post photographs of it on social media. The average Western person who considers eating insects as unacceptable thinks nothing of eating the extremely aged, mold-covered bacterial fermentation product of a cow's mammary gland. The disgust system is not calibrated to objective characteristics of food. It is calibrated to cultural categories. And understanding this is the beginning of understanding why changing it is so difficult. The food industry is paying very close attention to this problem, because insect protein is not going to stay a niche conversation. The economics and ecology of global food production are going to force it into mainstream consideration whether the mainstream is ready or not. The strategic response of insect food companies to consumer disgust has been illuminating. The dominant approach is concealment, processing insects into powders, incorporating them into products where they are invisible, and the label is the only indication of their presence. Cricket powder protein bars, insect flour pasta, mealworm fortified crackers that taste, to most consumers who try them without knowing, essentially like regular crackers. This approach works surprisingly well, at least in terms of consumer acceptance. Research on blind taste tests consistently shows that consumers rate insect-fortified products comparably to conventional equivalents when they don't know what they're eating. The problem is not the taste, the texture, or the actual sensory experience of consuming insect-derived ingredients in processed form. The problem is the knowledge, the mental image, the category association, the disgust response, triggered by information rather than sensation. This creates an ethical and strategic tension in the insect food industry. Concealment addresses the immediate problem of consumer rejection, but doesn't change the underlying disgust response. Transparency addresses the psychological root, but faces the barrier of that same disgust response at the point of sale. Companies navigating this tension are essentially trying to thread a needle between giving consumers what they need nutritionally and not triggering the psychological mechanism that prevents them from choosing it. Some researchers argue that the concealment approach is ultimately counterproductive, that it prevents consumers from updating their mental models of what insect consumption is and feels like, maintaining the disgust response intact for the next encounter. Others argue that exposure through palatable, disguised forms is the most realistic route to gradual normalization. The debate is ongoing. The crickets remain underutilized. Children represent a particularly revealing angle on this question. Food disgust responses in humans are not present at birth and do not emerge fully formed in early childhood. Infants and very young toddlers will put essentially anything in their mouths: insects, dirt, other people's food, objects that have no nutritional value whatsoever. The exploratory mouthing behavior of early childhood is indiscriminate. Disgust, including food disgust, is learned. It develops primarily between ages 2 and 8, shaped by parental reactions, peer behavior, cultural messaging, and repeated social cues about what is and isn't appropriate to eat. Studies on children in cultures where insect eating is normal find that children eat insects readily, without disgust, in the same way that Western children eat chicken nuggets without contemplating the chicken. Studies on children in Western cultures find that food disgust around insects can be reduced significantly through structured exposure programs. Having children handle insects, learn about them, cook with them, and eat them in controlled, positive social contexts. The implications are significant. Food disgust is not hardwired. It is installed during a developmental window, and that window can be filled with different content. The question of whether the next generation of Western children will have the same disgust responses toward insect consumption as the current adult population is, in part, a question of what food education, media representation, and cultural messaging looks like over the next decade. A 6-year-old who learns to cook with cricket flour in school and thinks of it as normal has a fundamentally different relationship with that food category than a 40-year-old who learned during their own developmental window that insects belong in the same mental category as dirt and garbage. These are two different learned responses installed in the same basic hardware. One of them is a better fit for where the food system is going. There are also real, non-psychological barriers to insect consumption that deserve honest treatment, because dismissing every objection as irrational disgust is itself an oversimplification. Allergen concerns are legitimate. Insects share proteins with shellfish, specifically tropomyosin, a muscle protein that is a primary allergen in shellfish reactions. People with shellfish allergies may react to insect consumption, and this is a real safety consideration that requires labeling, research, and consumer awareness. The insect food industry has not always handled this transparently, and the concern is not unfounded. Farming practices and welfare considerations are beginning to attract serious attention. Insect farming at commercial scale raises questions about the capacity of insects to experience suffering, questions that are not trivially answered. The neuroscience of insect pain and distress is genuinely uncertain. Insects have nociceptors, sensory neurons that respond to potentially harmful stimuli. Whether this constitutes anything like subjective suffering is hotly debated and unresolved. For consumers whose dietary choices are influenced by animal welfare considerations, this uncertainty is relevant and deserves engagement rather than dismissal. Supply chain infrastructure barely exists at commercial scale in Western markets. The farms, processing facilities, safety standards, distribution networks, and retail integration that would make insect protein accessible and affordable at population level are embryonic. Consumer acceptance is not the only barrier. Industrial and regulatory infrastructure needs to develop in parallel, and this takes time and investment that follows rather than precedes demonstrated demand. These are tractable problems. They are being worked on. But they exist, and acknowledging them matters because the conversation about insect consumption is sometimes conducted as though the only obstacle is squeamishness, which is reductive and unhelpful. The cultural journey of other foods that underwent normalization provides some genuine optimism about the trajectory of insect consumption in Western markets. Sushi. In 1970, sushi was virtually unknown outside Japanese communities in the United States. By 1990, it was appearing in upscale restaurants. By 2000, it was in supermarkets. By 2010, The idea that raw fish wrapped in seaweed was somehow exotic or unacceptable had become genuinely difficult to explain to the generation that grew up with it as a normal lunch option. The journey from foreign and alarming to grocery store staple took roughly 30 years and involved celebrity chefs, cultural exchange, demographic change, and generational turnover. Kimchi, sriracha, miso, matcha, hummus, quinoa. Every food that is now unremarkable in Western supermarkets was, at some point in recent history, considered foreign, unusual, or inaccessible. The mechanism that normalizes food is social exposure, positive experiences, and the gradual replacement of unfamiliarity with the casual assumption that this is just something people eat. Insects are further back on this journey than sushi was in 1970, but the direction of travel is observable. Insect-based products are in specialty stores, then mainstream health food retailers, then increasingly in conventional supermarkets. Food media coverage has shifted from novelty and disgust-focused framing toward nutritional and environmental framing. A growing cohort of younger consumers, particularly those whose dietary choices are already shaped by environmental considerations, are more receptive than older demographics. The disgust response is stubborn, but it is not immovable, and the ecological math is eventually going to make the conversation unavoidable regardless of how stubborn it is. Here is the part where the full weight of this conversation lands, and it lands hard. The global food system is under pressure from multiple directions simultaneously. Climate change is disrupting agricultural production. Freshwater scarcity is intensifying across the regions that produce the most food. Arable land is finite and increasingly degraded. The protein demands of a growing, increasingly affluent global population are rising faster than conventional livestock production can sustainably meet them. In this context, having access to a food technology that delivers comparable nutrition to conventional meat at 1/6 the resource input, and declining to use it at scale because of a learned cultural aversion that is demonstrably plastic and culturally contingent, is not simply a matter of personal preference. It is a civilizational choice with compounding consequences. The crickets on that deserted island were never really just crickets. They were a decision point. A test of whether rational knowledge about what something is can overcome the visceral, learned, culturally installed response to what something looks like. 2 billion people are already answering that question one way. They sit down, they eat the crickets, they get on with their lives, and they are nutritionally well served by the decision while contributing minimally to the ecological footprint of feeding themselves. The other third of humanity is standing there, apple in hand, watching the sustainability math get worse with every passing year, and hoping something changes before the apple orchard runs out of water. The most efficient food on Earth is sitting there, available, nutritionally superior, ecologically responsible, and affordable to produce at scale. The barrier between it and the people who need it most is not a wall, it is a wince. And walls historically are harder to dismantle than winces. The question is whether the wince goes away before the alternatives do.